Welcome to 8.2 Part 2 Notes, which is all about arithmetic series. And an arithmetic series is the expression formed by adding the terms of an arithmetic sequence. So in Part 1, we actually found those sequences. We looked at them. Remember, they were doing a common difference. So something was either adding or subtracting to find the next term each time. So a series is going to be the sum of all of those things. So we're adding all of those terms together. Okay, so what we're doing is using the formula down here and all of the parts in order to find the sum of the first n terms of the series. So my n still represents the term number, okay? My a sub 1 is always the first term. A sub n is the nth term, so when I figure out how many terms I'm using, I can plug that in to find my nth term, and then n is the total number of terms. So we're going to start by finding the sum here. Our rule or our sequence is made up by plugging in different term numbers for I. So it's saying start at 1 and go up to term number 20. So in order to do this, what we're going to find is our first term and our last term to start this out. So always start by finding your first term and your last term. Okay, so a sub 1 is me plugging in a 1 into our rule and finding out that our first term is 10. And it says stop at 20, so a sub 20, I'm plugging in a 20 for that I and finding out that our 20th term is 67. So then I'm going to use that formula that was on the last slide. Looked like this. And I'm going to plug in the pieces that I know. So I'm trying to find the sum of 20 terms. I know I have 20 terms total. My first term was 10, my last term is 67, and that is divided by 2 inside the parentheses there. So I'm going to simplify, and I get that sum is 770. Okay, I'm going to follow the same order on the next problem. So we're going to start by finding our first term and our last term. This time it says we have 15 terms total. So I have a sub 1 and a sub 15. I'm plugging those numbers into our rule. And I get that my first term is a 2. And then when I plug in my 15, I get that the 15th term is negative 26. So then I'm going to find my sum of 15 terms by plugging in that I know I have 15 terms. My first term is a 2, my last term is a negative 26, and I'm dividing by 2. So that sum is equal to negative 180. We can also find the sum without having that summation notation, but it takes a little bit more work. So what we're going to do first is actually figure out what our rule is or what our sequence looks like. So in part 1, we learned how to write the sequences. We had this formula, a sub n equals a sub 1 plus n minus 1 times d. So we're going to figure out what that is, and then we're going to write it in summation notation and figure out what the sum of the first 40 terms of this series are, or this sequence. Okay. So what I'm going to look at first is finding out what my common difference is. So for each of these numbers, I am adding 8 each time. So I know that my common difference is 8. And refer to part 1 if I lose you at any point, because that is where we figured out all of these pieces and how to write the sequence. So we have a sub n equals, and our first term is a 5, so I'm going to plug in 5, n minus 1, and we just figured out we're adding 8 each time, so common difference is 8. Okay, I'm going to distribute that, so I have 5 plus 8n minus 8, and when I simplify, I get 8n minus 3. Now remember, when we write it in summation notation, I write it with an I instead for our index. So I'm going to write that 8i minus 3. I'm starting at my first term, and I'm going 40 terms in. Okay, so we know that our first term is 5, and we need to figure out what our 40th term is. So that's 8 times 40 minus 3, which is 317. And now that we have both of those pieces, we can actually figure out what the sum would be. So sum of the first 40 terms is 40 times 5 plus 317 divided by 2. And when we simplify that, we get 6,440. Okay, here we have a finite arithmetic sequence, which means I only have a specific number. There's not a ... at the end here. So I can actually figure out how many terms there would be without the equation or the question at the top telling me with the first so many terms. So I am still going to write my equation over here for my sequence. So I'm using that same formula again. I'm figuring out what my common difference is. So each time in this one, I am subtracting 4. So my common difference is going to be a -4. And I know my first term is now a 6. So I'm plugging that in with my -4. I'm going to simplify. So I have 6 minus 4n plus 4. And so my rule is a -4n plus 10. Okay, so when I write my summation notation, I'm going to have -4i plus 10. And I know I'm going for my first term, and I have to figure out how many terms it would take me to get to -30. So if I'm subtracting 4 each time, that's going to be 10 terms. So what I know is I need the first term, and I need the 10th term. So my first term was 6. My 10th term, I'm plugging in a 10 into my equation, and I get that that's -30. Remember, that should match the original sequence listed, okay? Because I don't have a ... at the end, so what I wanted was for it to match, okay? So now I'm going to write out my sum of 10 terms times 6 plus my -30 divided by 2. And simplify, so the sum of those 10 terms is -120. Okay, for the last two examples, we're going to work backwards in order to try and figure out how many terms are in this sequence. So right now, I've got my total sum, and I have my rule, and then I'm starting at 1. So that's a little bit helpful. I just don't know where I'm ending. So that's what I'm trying to figure out, is how many terms are in this sequence. So the first thing that I can do is actually figure out what that first term is. So I have -4 times 1 minus 1. So I know my first term is a -5. The problem is I don't know where I'm ending. So I have a sub n, and all I can do is just plug in an n in that equation. Okay, I don't know what that n is, so I'm just plugging in an n. So -4n minus 1. Okay, I do know that the whole thing equals -1,127. So when I set this up, I'm going to use that original formula that said S sub n equals n times my first term plus my last term over 2. Okay, so I know what I'm plugging in as my sum, -1,127. I don't know what n is, but I'm going to plug in what I know over here. So my first term is a -5. And then I'm adding to that -4n minus 1, and that's divided by 2. So now I'm going to simplify what's inside the parentheses. So I have -4n minus 6 divided by 2. Oh, I forgot my n on the outside. There we go. Okay, and what I'm going to do now is actually divide those by 2 because they're both even numbers. So I end up with a -2n minus 3. I'm going to distribute my n. So I have -2n squared minus 3n. And at this point, since I have an n squared, an n, and a constant term, I know that I should get everything to one side, and I should be able to factor this. So I'm going to move everything over. And I'm going to get 2n squared plus 3n minus 1,127. Okay, when I factor this, I get n minus 23 and 2n plus 49. And what I'm really looking for is my positive term, because I'm looking for the number of terms in the sequence, and you can't have a negative number of terms. So instead of saying I have -20 terms, I want the positive number. How many do I have? So the only one that gives me a positive is the n minus 23, because when I add 23 to both sides, I get a positive number. So number of terms in this series or sequence is 23. Okay, we're going to do one more of those. So again, I'm going to start by trying to find my first term and my nth term. So my first term, I'm taking 3 times 1 plus 5. So I get my first term is 8. I don't know what my second term is, so I'm just plugging in that n value there. And then I'm going to plug everything in to that formula. Okay, don't know what my n is. Here's my first term plus my nth term divided by 2. I'm going to simplify what's inside the parentheses. So now I have 13 plus 3n divided by 2. And I realize those are not even numbers this time, so instead of dividing inside, I'm going to solve on the outside. So I'm going to get rid of that n. So I have 544 divided by n equals 13 plus 3n divided by 2. I'm going to multiply by 2 on both sides. So I have 1088 divided by n equals 13n, or 13 plus 3n. Multiply that n back over. So I get 1088 equals 3n squared plus 13n. Now you could have done that up at this step and just multiplied by the 2 instead, but a lot of times my students don't see that, so that's why I multiplied by n first. I'm going to go ahead and subtract my 1088 over. So I have 3n squared plus 13n minus 1088 equals 0. Again, I'm going to factor this. So this time I get 3n plus 64 equals n minus 17. I'm looking for the positive answer. So I have n minus 17 equals 0. And when I add the 17 over, I get a positive 17. So there are 17 terms in this series or sequence. Okay, make sure that you guys are asking questions either through Teams or through email. If you get stuck on anything, let your teacher know. 8.2 is a lot to take in, so let's make sure that if you have questions, you're asking questions, and good luck on your assignment.